In this example here, we're going to do the exact opposite of what we did in the first two. Now we're going to take the graph and we're going to reverse engineer the inequality out of it. If you remember back from Foundations of Pre-Calculus 10, the equation of any line is y equals mx plus b. And we're going to base our work off of this because we do have a line in this inequality, but we also have the shading. That's a consequence of the inequality, and we'll deal with that as we go. But we do need to determine two things. One, m, the slope. The second is b, the y-intercept. Well, the y-intercept we can get just by looking at the graph. Where does the line itself cross the x-axis? Crosses it right there at 1. So we have a y-intercept of 1. The slope of any line is the rise over the run. To find that, we need to look at 2 points along the line, making them as far apart as possible while still being good points. So this one right here at the very left end of the line is not a good one. Just because it's in the middle between 2 points, we would have to guess a little bit at it, and we want to avoid that when we can. So I'm going to pick this point right here, and this point almost at the top of the line here. Looking at those 2 points, going from left to right, we have risen by 8. And our run is 4. I know my drawing kind of goes out a little bit just because I couldn't get a straight line with my finger there. But it is 4 that we go over, so that reduces down to 2. So putting that back into the inequality that we're developing, slope is 2, that's m. So we have 2x plus 1. We will have a y, but we don't have an equals anymore because now we need to take into account the shading from the inequality. Now, to figure out whether this is a greater than or a less than, we look at the line and we look at where things are shaded relative to the line. All of the shading is above the line, and we need to think about this in terms of above and below. Even though it looks more like the shading is to the left, we can't talk about left and right because we're talking about y. The y-axis is up and down. The shading is above the line, so y is greater than 2x plus 1. The last thing we need to take into account here is whether or not y is just greater than or y is greater than or equal to. For that, we need to look at the line itself again. It is a dotted line, and as I mentioned back in example 2, dotted lines do not have equal to with the inequality, so this one would be done at y is greater than 2x plus 1.